In this video, we look at parametric representations for the solution sets for linear equations. So if you visualize the first equation here, 2x minus 4y equals 0, that'll be a line when x is 0, y is also going to be 0 to solve that. So you can imagine this is a line that goes through the origin, and it's going to have infinitely many solutions. Any point in that line is going to be a solution for the system. So we describe the set of all solutions for a linear equation as a solution set. And when we want to describe the entire solution set, we use a third variable and create what's known as a parametric representation. So because this is two variables, x and y, we have a third variable. In example B, we've got three variables, so we're going to have what's known as two free variables in our parametric equation. So we can choose either variable as our free variable. What that means is once we know the value for that variable, then we can work out the value of the second variable, or in the case of equation B, the first two variables would determine the third variable. So that last variable is not a free variable because you calculate it based on the first two variable values. So we are going to let y be the free variable in this first example, and we'll say y equals t. The common parametric variables are s and t. And so now we want to solve x in terms of t. So we're going to have 2x minus 4t equals 0. And then we've got 2x equals 4t, moving our equation over to the other side, our t over there. And then we can simplify this to say x equals 2t. So we would describe our solution set as x equals 2t and y equals t, where t can then represent any real number. So what this has done is given us a solution set in terms of just one variable t. Otherwise, we'd have our solution set in terms of both x's and y's. So by introducing this third variable, now we just have variable t, one variable for our solution. All right, let's look at example B. So in example B, now we are going to have two free variables because we've got three variables in the system. So we'll let y be s this time and z can be t. Usually we go in alphabetical order. And so we are going to have a new equation that says x plus s plus t equals 1. And then if we want to get x by itself, we'll say, okay, well, x is 1 minus s minus t. So we would say our solution set is x equals 1 minus s minus t, y equals s, and z equals t. So what this has given us is now a solution set in terms of two variables instead of three. So by parametrizing our equations this way, we are eliminating that third variable and simplifying our equation in terms of just the two free parameters. And so this comes to our advantage when we're working to solve problems or doing programming to have less variables at our in our equations. So this right here is our solution set for equation B.